Welcome to our lesson, our video on differentiation using definition of derivative. There are several techniques of getting derivatives or differentiating, but in this video we'll only look at how to do differentiation using the definition of derivative. In our other videos we'll have to look at other techniques of differentiating. So before we look at examples on how to differentiate using the definition of derivative, we would first of all want to define what a derivative is. And if you're given a function f of x, then its derivative at a point x will be defined by f prime of x, and is given by the limit of f of x plus h minus f of x over h as h tends to 0. So this is the definition of derivative of the function f of x. If that limit exists, then the derivative would be given by this. Now there are some things you need to know. One is that if f prime of x exists, then our function f of x is said to be differentiable. So we only say that this function is differentiable if its derivative f prime of x exists. And the process of getting this f prime of x, the process of getting this derivative, is what we call differentiation. Now, when you're using this formula to get derivative, if you're using this formula, then we can say you are differentiating by use of definition of derivative, or you are differentiating from first principles. So to differentiate using limits, if you are asked to differentiate using limits, or you are asked to differentiate from first principles, or you are asked to differentiate using definition of derivative, and then what you are supposed to do is to use this definition 1 to get derivative of that particular function. And that is what we want to do. Let's look at our examples. Example 1 says differentiate f of x, which equals to x squared plus 4 from first principle. And then after differentiating, determine the value of the gradient of the curve at point x equals to 4. So that's what we are supposed to do. So the first thing first, we differentiate by our definition, and so that is part A. Let me just do that. Part A, we're supposed to get the derivative of f of x equals, example 1, f of x equals to x squared plus 4, and we have been told the method to use. We're supposed to use first principles or use definition of derivative. There are various methods, but let's restrict ourselves on the method given to us. So our solution is, we're supposed to find the derivative is given by, our derivative will be given by the limit of f of x plus h, f of x plus h minus f of x over h as h tends to 0. As h tends to 0. Let's just do that now. We know what our f of x is. Our f of x is this function. So now substituting, we have the limit as h tends to 0 of our f of x is that. So while there is x, you just adding h to that, and x was squared, and then there's plus 4. Then from this we subtract f of x, but our f of x is x squared plus 4, and then divided by h. So at this point you just you expand your numerator, and this would give us limit as h tends to 0 of x squared plus 2xh. You now to expand this numerator, and then plus h squared plus 4, and then minus x squared minus 4 over h. So at this point you realize that our x square appears twice, but this is positive and this is negative, so this 2 would give us 0. This 2 would give us 0 because x squared plus minus x squared will be 0. And then I also have a positive 4 here and negative 4 here. Positive 4 minus 4 would give us 0. So what you are left with is limit as h tends to 0 of 2xh plus h squared over h. At this point, since we are avoiding division by 0, we have to factorize our numerator and then cancel out the h, so that we have no h in the denominator, because plugging in h here, h is 0, so if you plug in, you would have division by 0. So let's just factorize the numerator, and this gives you limit as h tends to 0 of h into 2x plus h over h, so that this h cancels that, and you are left with limit of 2x plus h as h tends to 0. Now at this point, since we have no since the denominator is not there, we are not in the danger of division by 0, so we now plug in h. Where there is h, you plug in 0, so we'll have 2x plus 0, so our answer becomes 2x, and that is the answer to this derivative. Now let's go back to our question and see what the question wanted us to do. The question wanted us to find the gradient of the curve when x is 4. When x is 4. So let's see. So when x is 4, our gradient would be 2 times 4, which is 8. 2 times 4, which is 8. So that's how we do that question. We've answered that question exhaustively. So we look at the next question, the next example. Find the derivative of the following using the definition of derivative. Using definition of derivative. So again, we just using the same definition. Our definition was, let's just see what our definition was again. This was our definition of derivative. So that is what we are using again to do example 2. So let's do it at the bottom here. So example 2a, we're supposed to get, first of all, our formula. Our definition for derivative is the derivative of f of x is given by a limit of f of x plus h minus f of x over h as h tends to 0. Now, so if we substitute in our function, this function here, so what we'll be having will be limit of where there is x, we just adding h. There's an x here, so we add h, and the x was squared, so we square, and then plus 3, there's an x, so we add an h, and then minus 4, and then minus f of x. Our f of x is 7x squared plus 3x minus 4, and then over h as h tends to 0. So this is same as limit. So let's just expand the numerator, because you can see this is 0. We cannot plug in h. You have to first of all simplify our numerator. So doing that, we would have, as h tends to 0 here, we would have 7 into, expanding that, we would have x squared plus 2xh plus h squared. We are done with that first bracket, and then plus 3x plus 3h minus 4 minus 7x squared minus 3x plus 4. So what I've just done is I've multiplied by this minus inside bracket, and so you get 7x squared minus, and then minus 3x, then plus 4 over h. So let's just continue simplifying and see what we get. So this will be same as a limit as h tends to 0. Now let's open this bracket, and we would have 7x squared plus 14xh and then plus 7h squared, 7h squared. So I'll just open the bracket here by expanding this, and then minus, no, it's plus 3x plus 3h minus 4 minus 7x squared minus 3x plus 4 over h. At this point, you'll notice that there are some that are similar. For instance, this 7x squared is similar to this but different in sign, so they give us 0. 7x squared minus 7x squared will give us 0. There's this 4 here negative and plus 4. Again, that will give us 0. Let's check and see if we have another one. We have negative x 3x and then positive 3x. Again, that will give us 0. So that means we now have limit. What is left there is 14xh plus 7h squared plus 3h. 14xh plus 7h squared plus 3h over h. As h tends to 0, you can now factorize h again in the numerator, and we'll be having a limit as h tends to 0 of h into 14x plus 7h plus 3 over h, so that this h and this one cancels. We'll be left with the limit as h tends to 0 of 14x plus 7h plus 3. So at this point, since we have there's no danger of division by 0, we plug in our h equals to 0 to get the answer as 14x plus 3, since this one becomes 0. H is 0, so 0 times 7 would be 0. So we are left with 14x plus 3 as the answer to this function, the derivative. So this is the derivative to the function given to us. And let's look at the other example. So the other one was the derivative of, as I want to enlarge a bit, and to enlarge the questions a bit. Okay, so part B, we are asked to find the derivative of f of m, which equals to 7m over m squared plus 4. And again, we are using definition of derivative, so it will be easy for us because we already know what to do. So by definition, our derivative will be given by limit of f of m plus h minus f of m over h as h tends to 0. And if we substitute, what we then have will be 7, there's an m here, so we add h, over, there is an m here, so we add h, and that m is squared, so we square this, and then plus 4, then minus f of m, and f of m is 7m over m square plus 4. The whole thing is divided by h, so let's just say over times 1 over h. That's the same as dividing the whole of it by h. So at this point, it's obvious to us that since we are subtracting fractions, we need an LCM to do this. So for us to simplify, we require an LCM. So this is the same as the limit as h tends to 0 of our LCM here is m plus h square plus 4, the whole thing multiplied by m square plus 4. This is our LCM. So this would go here, m square plus 4 times. So this m square plus 4 times multiplied by our numerator, what we then get is 7m plus 7h multiplied by m square plus 4. And then minus this one, this denominator will go here, this number of times, it go there, m plus h square plus 4. So then what I have here will be 7m into, let me just expand this, and expanding that I have m square plus 2mh plus h square, and then plus 4. Okay, this becomes limit as h goes to 0. We now want to expand our numerator so that we see which ones we cancel out. So expanding the first part there, we get 7m cubed, and then 7, that's 28m. This is 7h, so multiplied by that we have 7m square h, and this times that we have again 28h. Coming to this, we have minus 7m cubed, and then there we have minus 14 m square h, and this one you have minus 7 mh square, negative 7 mh square, and this one you have negative 28 m. We have no problem with the denominator, so we just write it the way it is. There is no need of expanding it. So this will be m plus h square plus 4, the whole thing multiplied by m square plus 4. So let's check out which ones will cancel out. I have 28m positive and then negative 28m, they'll cancel out. I have positive 7m cubed and negative 7m cubed, they cancel out. I have this one is 7m square h, and then there's a negative here, 14m square h. Okay, seems like we've already cancelled out the ones which are similar, all of them. So let's now simplify further. Let us simplify further. So what we have now is limit as h tends to 0. Now this is 7m square h and this negative 7m square h, so the two give us negative 7m square h. So we are done with this and this. We are left with 28 h, and then there's a negative, is a negative 7m h square over the denominator, still the same denominator, and it's m plus h square plus 4, everything multiplied by m square plus 4. Seems like we left our h somewhere, so we come back. This, yeah, we left our h, 1 over h here, so this one was supposed to be times 1 over h, this one is supposed to be times 1 over h, and then back here we also included times 1 over h. Now, so factorizing our h outside in the numerator, we would have the limit as h tends to 0 of, this is h into negative 7m square plus 28 minus 7mh over the same numerator we've been having, the same denominator, m plus h square plus 4 times m square plus h multiplied by 1 over h, so that this 1 over h cancels with that. We are now out of the danger of division by 0, because you can see that if I was to plug 0 here, I would have m plus 4, and then here if I plug 0 I would have m, so the denominator is not going to 0. So that means what we now have, we can now plug in our h, and that gives us negative 7m square plus 28. This would become 0 because h is 0 over, this is 0, so m square plus 4 and then close multiplied by m square plus 4. We may want to go further and even factorize our numerator and say it is 7 into 4 minus m square over m square plus 4 everything squared. So this becomes the derivative. This becomes the derivative of the function given to us. Okay, let's look at the other question, the last example. And it was the derivative, it was g of x equals to the square root of 5x plus 4, and then we're supposed to find g, the derivative when x is 1. So what we are given is g of x equals to square root of 5x plus 4. So again, let's use our definition. Let's use our definition of derivative. So g prime of x equals to limit as h tends to 0 of g of x plus h minus g of x over h. So substituting in our equation there, we would have a limit as h tends to 0 of 5x plus h plus 4 under this square root and then minus g of x is square root of 5x plus 4 over h. So you can see that we have our roots in the numerator, which tells us that we must rationalize that numerator. So to do that, we multiply both the numerator and the denominator by the conjugate of the numerator. So let's just do that. This is 5x plus h plus 4 minus 5x plus 4. Let's multiply by the conjugate of the numerator on both sides, both the numerator and the denominator. So multiply by that conjugate, we have this plus 5x plus h plus 4 plus 5x plus 4 over 5x plus h plus 4 plus 5x plus 4. So this is the same as limit, and we know how to multiply this. So we are multiplying, just multiplying the normal way we do. So multiplying this part with this part gives us what is inside the square root, which is 5x plus 5h plus 4. Then minus multiplying this part and this part gives us what is inside the root, and that is 5x plus 4. There is no need of simplifying the denominator, so let's just leave it the way it is. 5x plus 5h plus 4 under the roots plus 5x plus 4 under the root, close the bracket. Now, so the numerator can be simplified further. The numerator can be simplified further, and so that gives us a limit as h tends to 0 of 5x plus 5h plus 4 minus 5x minus 4 over h of a root of 5x plus 5h, just a minute, this 5x plus 5h plus 4 plus 5x plus 4. Let's close this bracket. At this point, you notice that this and this will give us 0, and then this and this will give us 0. So we are left with a limit as h tends to 0 of 5h over h multiplied by root 5x plus 5h plus 4 plus root 5x plus 4. This is x, 5x. Close the bracket. So that this h and this h goes. Now we are out of the danger of division by 0, so we can now plug in 0. We can now plug in 0 at this point, and what we get will be limit. Now let's just plug in 0. So let's plug in 0. Our numerator will have 5, and our denominator, this one goes to 0. This 5h goes to 0. That we have a square root of 5x plus 4, and then plus square root of 5x plus 4, which is the same as 5 over 2 times root of 5x plus 4, and that's the result. And the question says that we should get when the derivative when h is 1, when x is 1. So when x is 1, the answer becomes 5. This is 1. 5 plus 4, which is 9. The square root of 9 is 3. 3 times that is 6. So this becomes our answer. So let's do we'll look at other videos next time, where we'll be looking at other techniques of finding derivative. Thank you.